And welcome to today's debate on conformal coating inspection. With more electronic assemblies destined for harsh environments, demand for advanced conformal coating systems and materials is rising rapidly. This panel will explore the latest processes, equipment and formulations, sharing practical use cases and highlighting best practices for achieving reliable protection and inspection in modern electronics manufacturing. So I'm joined today by a large and very illustrious panel. To my extreme left from Viscom we have Jesper Leike.
Hello.
Hello. Next to him we have Abby Tsoi from Anda Technologies.
Hello.
Hello. Thank you. And then next to him we have Nico Kunin from Plasma Treat.
Hi everybody.
Right, there we go.
That's okay.
Being fed the microphone there by Marie Kane from Chase Corporation.
Hello.
Okay, so welcome everybody. We'll start off with you, Marie, actually, because this question is, as coating geometries and film thicknesses become more complex, what are the biggest inspection challenges you'll see on the line, and how are IPC and other industry standards evolving to keep pace with it?
Very good question to start with this panel discussion. Yes, today I think there are three main challenges in terms of conformal coating automated inspection. It's regarding the presence and the absence of coating, how we respect coating diagram and where the coating should be or should not be. That's the number one. Number two is about identifying, quantifying the defect, for example, bubbles, how many, how big they are. And the third one I would say is about measuring coating thickness accurately, repeatedly and reproducibly. So all those three type of things that we're looking for in conformal coating are challenges today.
And just to throw something in the mix there was a new coating system came out, I think I saw it for the first time at SMTAI, which was a dipping system where it's using a nano coating, and it's so thin that you can dip the whole assembly in and even the edge connectors won't be affected. But I'm guessing that's using too much material, but that's just another variation that's out there. Thought I'd throw that in. Anybody else got something to say on the topic here of the coating thicknesses and becoming more complex, and how the industry standards are evolving to keep pace?
Yeah, man, I can give a few words as well. So, I mean, I absolutely agree. Those are definitely some of the challenges. And for the camera purpose, I mean, you would need some very, very strong LEDs because, as you just said, there's sometimes nano coating on it. That means it's not very thick. Yep. And if you just do the standard milliseconds, then you don't see it really, the reflection on the UV reflective. But if you have some very, very strong LEDs that would flash really, really fast and really quick, obviously, then you would actually see that, let's say, coating of it. And quite often you also see that there's challenges when it comes to what people are used to, the manual inspection and then the automatic inspection, where you would then have some discussions, obviously. So one thing is defined on paper, but what you also see in real life is a different story, because a machine, for instance, will be very, very accurate, whereas manual, you're a little bit more forgiving sometimes and whatnot. Yeah. So that's also a challenge, I think, that the process and the paper process needs to be in place.
Okay. Abby, are you seeing, are you handling nano coatings much, or are your customers using your coating systems to apply nano coatings very often?
Yeah, some customer is a nano coating is that, but I have no information is what they are facing any challenge or that. That right now Anda do not have the AOI at this moment. So maybe the AOI guy, and then to have more information about that.
Right. Okay. Moving on. Yeah, you can do.
I mean, you're talking about nano coatings, and of course, you can apply a nano coating with plasma.
Yeah.
And
you can apply it with plasma.
Yeah. You bring in the precursor within the plasma, and you polymerize a very thin layer. You talk typically below 1 micron.
Okay.
And and again, the challenge is how can you detect this? I mean, if you have to go below 1 micron, it's very hard to use any UV tracers in there. So from a inspection point of view, these nano coatings are challenging.
Right.
I think there is a market for it. It's a niche market because the properties are not the same as a coating thickness of 100 micron, but there are applications specific benefiting from that. I would say like electronics in drones because of the weight.
Right.
If you have electronics in virtual glasses where the space is limited. So I think the nano coatings are having their place, but it's limited.
Limited applications at this point. Okay. All right. Well, thank you for that. Next question is on process control and automation. How are modern vision and UV-based inspection systems integrating with coating robots and MES platforms to enable real-time process control and closed-loop feedback? We'll start with you again on that one, Jesper, because I mean nowadays people are looking for more and more automation into the systems. Are you finding that you need to integrate better with the coating manufacturers, coating systems?
Yeah, I mean that absolutely helps, definitely, and we're absolutely, as always, willing to work with everybody, of course. So that is definitely something that people are looking at. It's not only a yes/no answer, right? So the MES control after that, they need to know exactly what was coded, what was not quoted. They need to be able to pull up that data afterwards. Possibly even save that data for 10 years or 20 years or whatever, because it's again a liability thing. So by all means, then data is important for sure, and as you mentioned as well, speed, absolutely. So it needs to be faster these days. Nobody has time for anything, so it needs to be super fast.
Right, but you're doing only an inspection element of it. So I mean, you would integrate with either with an ANDA system or with any other of the other coating manufacturers, a Nordson system, to bring that level of automation in.
Yeah, so we are obviously, yes, again, the automation part, if that's with a robot, we don't care how they apply the coding, but we'll be happy to take a look afterwards and then again provide the data. So there's liability there and let everybody know.
Okay.
Yep.
Abby, what are you doing to try and increase the automation and make it an end-to-end process, without, one man? I think you've got a one-man system, haven't you? One-man operation, it's called?
Yeah, I think the next generation of the coating inspection will be inspection on the fly.
Right.
In coating machines. That means we have the inspection camera integrated with our coating robots.
Right.
And there is not only the hardware, and then the most important is the software, and then that the image captured while we are doing the coating. And real-time information and feedback, and the system, the software can tell the coating machines whether they need to update their program, if there is any, the requirement concerned.
Okay.
So I think this is the trend, and AOI equipment makers should be work with the coating machines maker together and make this happen. I think this is trend is the smart manufacturing is everything is the automation.
Yeah,
so
absolutely.
why you make the automation happen correctly, and then we need everything to feedback to the machines to do the correction if required.
Right.
So that's why the inspection on the fire will be the ultimate solution and make the coating successfully.
Right. Of course, one of the things that's driving the automation is the fact that we can't get enough operators, or the manufacturers are finding it difficult to find people to hire. So one way of trying to, get around this problem is increase the amount of automation in the factory. Nico, are you trying to increase more of the automation in the plasma treat, and both in the coating and the inspecting?
Yeah, of course. Automation is kind of important, but I think it comes down to, like you said, if you want to have a one-man operation, right?
Yeah.
You want to eliminate all the unknown factors, and I think that's where plasma pre-treatment before the conformal coating typically comes into play. If you do a pre-treatment before the conformal coating, typically you can eliminate differences in PCB quality, components that have mold release and so on. So typically we see a lot of interest of people who want to add an additional process step just to make sure that the quality level is there so that basically they can run without too many issues, because conformal coating is a difficult process.
Yes. No, I agree. Okay, Marie, here's a question for you on materials compatibility and detection limits. With new formulations, UV curable, silicon, parylene, etc., entering the market, how well can today's inspection technologies detect voids, bubbles, and coverage defects across different chemistries and finishes?
Yes, so in terms of conformal coating chemistries, all those material technology have different properties in terms of gloss level, UV tracer fluorescence level. They're all designed to provide good electrical insulation resistance, good protection against moisture, but they are not necessarily geared to have very good aesthetic finish, you know.
Right.
So what is very important for automated inspection system is to have the capability to accommodate a wide range of material with different gloss level, as I said, some with UV tracer being able to detect bubbles and measure coating thickness regardless of whether there is a UV tracer present inside, right? And being able to detect all those kind of defects, measure thickness regardless of the coating material chemistry.
Right, okay. And you, of course, have got brought out a recent coating where it gets around the problem of the sharp corners on the edge of devices, you know, where you get extra coating on the side of these devices to maintain the thickness, you know. Yeah. Okay. Anybody else got anything to add on the materials, the inspection side? Maybe back to you, Jesper, on that one. So, you know, there's different ways of, you know, inspecting the voids, the bubbles, the orange peel, etc. You know, what other things can you look for in terms of inspection?
Yes, as we already talked about, I mean, definitely the intensity of the LEDs is one thing, but there's also different angle of LEDs, so it depends on where you shine the light, it will reflect different. Okay. And sometimes, obviously, as we talked about, bubbles or foreign objects and whatnot, they light up more in one direction because you don't know, let's say, specifically what foreign object you have there, so you need to find some illumination that highlights it. Yep. Obviously, also some thickness sensor is important in certain areas where you can go and spot check and make sure you have the right amount, if that's nano coating or not. Mm-hmm. It doesn't really matter. But yeah, basically have some options, multiple options of different lights and different inspection methods, different algorithms, if it's component-based, if it's just tile-based, if you need to inspect the whole board, if you have some keep-out zones, all that obviously is very important, yes.
Yeah, okay. Abby, back to you. So what trade-offs exist between inspection speed and accuracy, and how are manufacturers optimizing inspection coverage without slowing down high-mix production lines?
Your question is the speed and
what
accuracy.
What trade-offs do you have to make? You know.
My answer is very similar to my answer to the previous questions. Is inspection on the fly. Mm-hmm. That is that you inspect and coating and doing at the same time. So it doesn't matter, the time issues anymore.
Right. So if you're doing it on the fly, then that's the fastest way.
But however, there is one disadvantage of inspection on the fly for coating material when the material with a high viscosity. Mm. It takes some time to spread out and to have the fluid cover the area you're going to work.
That's true.
However, and we can have the plasma machines, plasma before we do the coating, and then to avoid, to help the spread out of the material.
Right. So if you use plasma treatment before the coating, you get better. It wets better. The material wets better throughout the board coverage. Would that be right?
So this
Nicole?
would be to avoid dewetting. That's the coating defect you're describing. It's called dewetting.
Okay.
And that's the ability of a coating to not wet properly a substrate. When you have contamination or very low surface energy, plasma treatment or any kind of cleaning or surface treatment process helps raising the surface energy up so that the coating wets better onto the surface.
Yeah. Okay.
I think it comes down that you have a stable process.
Yes.
Because you have very different variables. So you have different PCB manufacturers, you have different components. If you do a plasma step before that, basically you change the surface energy to a certain level. You know that level. And if you have that as a constant, of course, your coating will react constant to that surface level. And I think that is important to have a very stable process.
Yeah. Okay, that makes sense. Jasper, back to you. So how do you see AI and machine learning reshaping coding inspection over the next 5 years? And will we move towards predictive analytics and automated defect classification at scale?
I mean, it's already there, so so that's not even 5 years out. I mean, it's absolutely there already. So the more AI we can put in, the more we can take, let's say, the operator, the questions out of it, and that's where AI helps. It's already proven. I mean, you have the data, so it's very easy for the AI to just go in and verify if that's an operator call, if that's the machine. We do obviously also wet and dried coding and whatnot. So the AI is already there since years, honestly. But it will be even more, of course, yes, as AI evolves, for sure. But it's very exciting times where AI can absolutely help you tremendously in speeding up the process. You don't have to have an operator sit there and verify everything. It will be more and more automated, and it already is.
It's only going to increase, get more automated. You're right. Abby, are you using any AI in your systems yet for conformal coating?
Yeah, this is for sure. And for an AI involved in the machinery, every machine makers now is using the AI, a certain level of AI inside already. But for the coating machines, for the futures, and there will be an all-in-one machine in a single wash cell. That means including the plasma treatment, coating, inspection on the fly. They collect all the data and has a big database.
Right.
And that's the how to improve the process or the real-time corrections to the production.
So you have an end-to-end line, and you're collecting all the data and analytics.
Yeah. That's the trend of the market.
And the trend.
Conformal coating machine.
Yeah, exactly. Okay. Nico, are you actually using much AI in your systems?
Actually, not right now. I mean, the plasma process doesn't need to be so precise as a conformal coating process. So I think the process itself is quite forgiving. So the process window there is so far we haven't seen the need to implement AI, but we'll never know what happens.
Right. Okay, great. Well, I think we've pretty much exhausted the discussion today. I want to thank everybody for taking part. Jesper Leike from Viscom, Abby Soy from, of course, from ANDA Technologies, Nico Coonan from Plasma Treat, and Marie King from Chase Corporation. Thank you, ladies and gentlemen, and thank you to our audience for watching today.
Kaizen is the leading global supplier of award-winning cleaning chemistries for electronics assembly operations. Whether you are cleaning stencils or final assemblies, our global team of cleaning experts is there to help you succeed. Want to know more? Stop by our booth or visit kaizen.com.